Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. In this class, we will talk about research motivation and we'll also talk about the steps that are involved in scientific research. The fundamental motive of research may be either of these three. Number one, refine existing fundamental principles. Number two, apply these principles for conceiving engineering products. And number three, based on the context of use, improvise the existing engineering products. This magic quadrant is an adaptation of Paaschi's quadrant that tries to describe different types of research based on two important aspects, which are understanding of fundamentals and perspective of use. Let us now start with description of the different types of research. Pure basic research is a type of research that emphasizes only on understanding of fundamentals. Pure applied research is a type of research that emphasizes only on perspective of use, whereas use-inspired research is a type of research that emphasizes on both understanding of fundamentals as well as perspective of use. The quadrant pertaining to pure basic research is also referred to as Niels H.D. Bohr's quadrant. The quadrant pertaining to pure applied research is also referred to as Thomas Edison quadrant, whereas the quadrant pertaining to use-inspired research is also referred to as Louis Pasteur's quadrant. In this magic quadrant, you'll find the fourth quadrant where both the aspects are absent. As a researcher, it is very much important for all of us to not venture into this quadrant while initiating a research problem. Now let us try to understand steps that are involved in scientific research with the help of this simple diagram. Scientific research starts with problem that exist in real world or a real world phenomena. Once a problem to be solved is identified, in the second step, we perform background and theoretical study. In the third step, we choose design and methodology to be pursued for performing research. In the fourth step, we collect all the relevant data based on the requirement of the research initiated. As we have discussed in the previous class, we may adapt to either structured approach or semi-structured approach or completely unstructured approach based on the availability and the organization or the orientation of available data. After the data has been collected, we execute the next step, that is statistical analysis of the data. The objective of statistical analysis is to draw certain statistical measures that would approve or disapprove the hypothesis that has been formulated. Then eventually we move on to a step dedicated for discussion, followed by conclusion. So these are the identifiable steps that are there in scientific research, starting with understanding of real world phenomena to background and theoretical study, followed by selection of design and methodology to be adapted, data collection, statistical analysis, discussion, and conclusion. In the first step, we try to identify the questions that needs to be answered in order to solve the problem. In the second step, we identify the concepts, we identify the variables, we identify the relationships, and eventually we try to create a description of the problem in hand. Now, this can be achieved through a detailed literature survey process. Now, once information is acquired regarding the problem that is to be solved, then we move on to formulation of hypothesis, prediction, and operationalization of research process. Once a hypothesis has been conceived, we need to collect the relevant data based on a specific situation or purpose of use. Once the data has been collected, needful statistical analysis is performed, inferences are drawn. These inferences will approve or disapprove the formulated hypothesis. Then we look onto the implications and possible bias or errors that has been committed. And in the conclusion, we will try to generalize our findings and specify certain future direction in the research initiative. To explain it in detail, scientific research involves examination, investigation, thorough understanding, seeking explanation, prediction, generation, testing, providing necessary information, constructing scenarios, measuring statistical matrices, adding, determining implication, and eventually disseminating the findings of research study. So these are the steps that are involved in scientific research. Now let us move on to some of the good characteristics that a research problem should exhibit. Research problem should be of your interest. If you do not have interest in a research problem, then better do not pursue it. So, a research problem should be of your interest. It should be of certain significance. It should contribute certain knowledge to the scientific domain as well as should be for the betterment of the society and mankind at large. A research problem should be delineated. It should be completely defined. A research problem should be easy to formulate. Data acquisition regarding the research problem should also be easy. And eventually, you should be able to draw certain meaningful conclusions from the statistical analysis. So, these are the goodness criteria that a research problem should exhibit. Now, research problem should not be to fill the gap of your own knowledge. This is very much important. It should not be a mere comparison of two variables. For an example, finding degree of correlation. Or research problem should not seek answer in yes or no form. So these are the aspects that a good research problem should not venture into or should not exhibit. So these are some of the shoulds and should nots of research problem. Now let us move on to an important aspect of research that is called as processing and analysis of data. Processing and analysis of data includes three identifiable steps. These are data collection, data processing, and eventually data analysis. As we have learned in the previous class, data collection can be done using either a completely structured approach or a semi-structured approach or a completely unstructured approach. So depending on the availability and the organization of the available data, you may pursue either of these three approaches for collecting data. Now data can be collected from primary source or secondary source. A typical example of primary source is if you use sensors in order to collect meteorological information, then it becomes a primary source. Whereas if you rely on data that has been acquired and presented by someone else, it becomes secondary source. But as a researcher, it is very much important for you to ensure that the data may be present in the primary source or secondary source is capable of preserving integrity. This implies data has to be properly validated. If data does not preserve integrity, then the overall finding of research initiative may not hold certain ground, which implies the overall value or the effectiveness of the analysis process depends on the integrity of data. So it's very much important as a researcher for all of us to ensure that the data is validated and it preserves certain integrity. Now, once the data has been collected, we need to process the data. Processing refers to preparing the data for analysis. Processing includes editing, coding, classifying, and tabulating. So once the data has been properly processed or represented, then we can use the data for analysis. Analysis basically refers to drawing certain statistical measure that may help us in approving or disapproving our hypothesis. So there are various statistical measures that can be derived from the data that has been processed. So these are the integral steps that are involved in processing and analysis of data. Now let us move forward and discuss each of these steps in greater detail. Let us start with processing. Processing includes editing, coding, classifying, and tabulating. Now let us learn about each of this activity in a greater detail. The objective of editing is to examine and scrutinize the raw data that has been collected. The aim of editing is to detect errors and omission as well as to correct errors and omission. The overall objective of editing is to ensure that the data is accurate, the data is consistent, it is uniform, it is complete, and eventually it's capable of facilitating operations or statistical operations. So, these are the objectives of editing activity. Now, there are two types of editing, namely field editing and central editing. Field editing is executed when the response is collected from the respondent in the field or at the time of collection, whereas central editing refers to editing of the response of the respondent in the research center once the data acquisition part is over. Now let us try to understand the importance of field editing. At certain situations or at times, it becomes difficult to decipher the response of the respondent. So, it is very much important for us to clarify all the doubts that may arise from the response of the respondent. So, at the time of collecting the response from the respondent, we try to retranslate or rewrite the forms, but we need to ensure that the errors of omission are not corrected because it may be intentional in the part of the respondent. So in case of field editing, the overall objective is to translate and rewrite the forms, which may at times be difficult to understand. Now, once the field editing is over, then we move on to central editing. Central editing is executed in order to hunt for common errors. Errors like entry in wrong places, entries that are inappropriate, missing replies, or entries that are illegible. While performing central editing, editor should be able to correct the answer or cancel the answers or contact the respondent in case if the editor wants to know the answer or mark the answer as no answer. But when you're performing central editing, editor should be well acquainted to the instruction or editor should be familiar with the instruction. Editor should be capable of keeping all the responses legible. Editor should use distinctive colors for representing the response of the respondent. And in situation, if the editor has incorporated any change to the response of the respondent, the change has to be initialized and eventually the form also has to be initialized. So this is the importance of central editing. So here we have learned that there can be two types of editing, field editing and central editing, and we have also learned the purpose for each of these editing types. Now let us learn about coding. Coding is a process where we tend to assign numerals or symbols to the response that has been collected from the respondent. This implies coding is the process of assigning numerals or symbols to the answers that has been acquired from the respondent. The only reason we perform coding is to facilitate classification or to remove the exhaustiveness of the data that has been collected. So if the data is properly coded, then we can classify the data into limited number of categories or classes. But whenever we perform coding, it is very much important for us to ensure that there is a class for every data item. Mutual exclusivity is looked upon and unidimensionality is also preserved. Coding facilitates effective analysis. It helps in creating classes that holds critical information required for analysis and it also helps in designing stages of questionnaires. But we need to also ensure that whenever we are performing coding, we adhere to certain coding standards. Now, let us move on to classification. Classification refers to creating a homogeneous group out of the large volume of raw data that has been collected. By homogeneous group, here it implies group that exhibits certain meaningful relationships. So classification refers to arranging data in groups or classes based on certain common characteristics. Now, there are two types of classification. Classification accordingly to attribute or classification accordingly to class interval. In case of classification accordingly to attribute, there can be two types of classification, simple or manifold classification. In case of simple classification, there will be only two classes, whereas in case of manifold classification, depending on the number of attributes, there will be number of classes. So in situation, if there are n number of attributes, then there will be 2 to the power n number of classes. So depending on the number of attributes, there will be number of classes. Now, classification accordingly to attribute is descriptive in nature, whereas classification accordingly to class interval is numeric in nature. Classification accordingly to attribute looks into presence or absence of attributes. This is also referred to as statistics of attributes. Whereas classification accordingly to class intervals is based on numeric value and it's measured through some statistical unit, and it's also called as statistics of variables. So in this class, we have learned about research motivation. We have learned about Magic Quadrant, which is an adaptation of Paasche Quadrant, where we have learned about different types of research. Then we moved on to various steps that are involved in scientific research, and we have learned about the steps in detail. Then we moved on to certain goodness criteria that a problem or a research problem should exhibit. Then we discussed a schematic representation of processing and analysis of data that highlighted the various phases. We have seen that there are three identifiable phases, which are data collection, processing of data, and analysis of data. Then we started with processing and we discussed the set of activities starting from editing. So we have learned about the objective of editing and types of editing. Then we discussed field editing and central editing in greater detail. Then we moved on to the importance of coding and the reason we need to code the response of the respondent. And eventually we moved on to classification, where we learned that classification is a process of creating a homogeneous group of data points that exhibit certain common characteristics. We also learned the type of classification. We learned about classification based on attribute and classification based on class interval, and we've also learned about their nature. So in the next class, we'll continue on with classification and then subsequently we'll move on to tabulation. Thank you very much. Have a very good day.